So we need to talk about fully factoring, which in some places is called completely factoring. On Thursday or Friday last week, we factored using greatest common factor and we factored using grouping, but we did not completely factor. We just did those two things and we stopped. We didn't look at the rest of what we got and say, oh, can I continue factoring from here? And so that's what we're going to do. We're going to add in today is we want to completely factor. This just means we're going to factor until it's unfactorable. There's nothing left we can factor. This especially applies to greatest common factor. If GCF, if there's something that we can take out of every term and then we got a bunch of stuff left in the parentheses, we should check, can we factor the polynomial in those parentheses? All right, so for example, fully factor 5x to the 6th plus 2x to the 5th minus 5x to the 4th minus 2x cubed. So we want to factor this completely. So I'm going to write some thought process steps on the right and work out the factorization on the left here. So first thing we want to do is just check, is there a greatest common factor? Check for a GCF. Is there something that I can divide each term by? Is there something they all have in common? And so we usually check the numbers in the front, 5. Well, we can't divide all of these by 5 evenly. And we check the variables at the end. Can each of these terms be divided by x cubed? And the answer is yes. The greatest common factor is x cubed. And then we're left with all of this. So 5, oh, I'm sorry, that should be a 5, x cubed. So we divided the x to the 6 by x cubed, plus 2x squared minus 5x, x to the 4th divided by x cubed, just leaves the single one, minus a 2. So the x cubed divides and we're left with just 2. From there, we're going to ignore the greatest common factor. Like, this is still part of the problem, it's being multiplied. But we're going to check, can this stuff in the parentheses be factored anymore? Well, we're going to check, can we factor by grouping? Can we group the terms here into 2 sets and then factor each of those and then factor the GCF out of the greatest common factor out of whatever we get? So the answer here is yes. Yes, I can do that. And so the x cubed stays the same. But we can factor out x squared out of each of these. So x squared times 5x plus 2. Took an x squared out of both of these. These have a negative in common, so minus 1 times 5x plus 2. And then the greatest common factor here is going to be these two things. And so I get a 5x plus 2 times the x squared minus 1. And then we still have this x cubed term being multiplied. Okay, that's all well and good. And now here's where the fully factoring really happens. We factored by grouping, but we're left with this x squared minus a 1. That can be factored further. We can turn that into a product of two parentheses. If you remember back to last semester, probably around November, we were working with quadratic functions. So we said, okay, we should be able to factor the quadratic. And we had a method with a x box that we used, and so we're going to go over that right now. So we want to factor this quadratic, this x squared minus 1 function. And so quadratics are of the form ax squared plus bx plus c. And so what we did was we said, all right, we're just going to factor this piece. All the rest of it's going to stay the same for our final answer. So we're going to factor x squared minus 1. And so we list out a, b, and c. We say, okay, a is 1, 1x squared. B is 0, there's no single x. And c is minus 1. And then we draw our x, which has AC on the top and B on the bottom. Hopefully, this is ringing some bells. Okay, so A times C for this problem is -1. And then that's 0. And so what we're doing here is we're saying, okay, what numbers multiply to make AC and add to make B? For this specifically, what numbers multiply to make -1 and then add to make 0? Well, that's going to be 1 and -1. Oh, I'm sorry. Now the other piece of this is sometimes A is not 1, and so if A does not equal 1, you would need to use the box. So if you remember back to when we were doing this more completely, we need the box if A equals not 1. Now my plan, we may fail in this, but my plan is to not give you problems where A is going to be 1. A is going to be not 1. Like if A was 2, if we had like 2x squared here, my plan is to avoid those because this is already complicated enough and we don't need that. So that's the plan. We'll have to see how it works out. So the purple numbers here, the 1 and the -1, become the multiplication. So x squared minus 1 is the same as x plus 1 times x minus 1. And so my final answer is x cubed, so that stays the same, times x plus 1 times x minus 1 times the 5x plus 2. And that right there, that is our fully factored polynomial. That's our answer. Any questions so far? Fully factored means we go as far as we can with integers. Sometimes these aren't going to fully factor with integers, like the factorization might have a square root, and so we don't do that. We just only worried about integer numbers. No questions, Antonio, or you don't want to do this because I understand both. I understand. No questions? Let's do another one. They're not all going to be this long. Some of them might be longer too. Depends on the problem. 2x to the 6th minus 8x to the 5th minus 42x to the 4th completely. Why did I put 5x plus 2? So that was from, you mean why did I put it here or why did I put it here? Like how did I get it in the first place or why did I include it in my answer? Because we were at this point, right, we had x cubed times x squared minus 1 and then the 5x plus 2. Like this is our factored problem so far. We just need to factor this x minus 1 further, but these two, the rest of the stuff is all part of our answer. Still part of the problem. So I included the x cubed and I included the 5x plus 2 because they're part of what we had originally. We just need to turn this x minus 1 into these two things. And so I still need to include the x cubed and the 5x plus 2. Ideally is not the word I want. If we were to multiply this all back, we should get this thing, this original problem. And so we need that 5x plus 2 because without it, we're not going to get 5x to the 6th. There's no constants in our answer here besides the 5 to get our original problem. So yeah, we still need all the pieces here. We just turned the x squared minus 1 into two multiplication problems or two multiplication parentheses. Okay. For our new problem, we're going to do the same 3 questions. Is there a greatest common factor that I can divide out? Can I factor by grouping? And if not, is there a quadratic that I need to factor further? Is there stuff that can be further factored? So with this problem, there is a GCF, or greatest common factor. It's usually going to be the number on the front here and the variable amount on the back if it's in standard form. But each of these can be divided by 2, and each of these can be divided by x to the 4th. So 2 divided by 2, 8 divided by 2, 42 divided by 2, and then all of these divided by x to the 4th. And so if that's our greatest common factor, then I can factor it out, and I'm going to get 2x to the 4th times whatever is left is going to be an x squared, a minus 4x, and a minus 21. So I just divided each term by 2x to the 4th. And you should be able to double check if I multiply back, do I get what I started with? This stuff times 2 gives me 2. 2 times negative 4 gives me negative 8. And 2 times 21 gives me 42. So from here, I just ignore the greatest common factor. We need to factor this part further, this quadratic. And so we need A, B, and C for that. A, B, and C. A is going to be 1. B is negative 4. C is negative 21. So what numbers multiply to make negative 21 and add to make negative 4? Hopefully this rings some bells from last semester, because we did a bunch of these X box things. Two numbers that multiply to make 21. Well, 1 and 21 do, but those don't add to make negative 4. And 7 and 3 do. So the only question from here is, well, which one's negative? Because they have to multiply to make a negative and add to make this negative. That's going to be the 7. So that means this, well, this is the same as 2x to the 4th. So that's our GCF the same. But this quadratic here is going to turn into x minus 7 and x plus 3. And that's it. That one, we're done from there. And so we should be able to look at our multiplication here and say, okay, 7 times 3 is going to give me this negative 21, and negative 7 plus 3 is going to give me this negative 4x. And then if I multiplied everything by 2x to the fourth, I'd get what we started with. So we haven't changed any of the value. We haven't changed the value of the problem. We've just changed what it looks like. We turned it into multiplication. Any questions there? I've got one more I want to do. One more. There we go. Okay, so we check greatest common factor. We check factoring by grouping. I can already tell you, since this only has 3 terms here, we're not going to factor by grouping. It needs to have more than 3. So our greatest common factor, look at the first number and the last variable. So we're going to take out a 20 and an x. Now that's not a hard and fast rule. It's not always that you're going to be able to take out this whole first number here. But generally, if it's in standard form, probably the first coefficient and the last variable is going to tell us. Tell us about the greatest common factor. Okay, so if we take a 20x out, we're left with x squared minus 11x plus a 30. 30 times 20 gives us the 600. All right. So a for the quadratic in here, this x squared, a is 1x squared, b is negative 11, and c is 30. And so we say, okay, numbers that multiply to make 30 and add to make negative 11. So it's going to be 1 and 30, that doesn't add to make 11. 2 and 15 doesn't add to make 11. 6 and 5. Okay, so that's 6 and 5, but we need them to add to make negative 11. That means both of them need to be negative. And so we get 20x, so that was the greatest common factor we factored out, times x minus a 5 times x minus 6. And that's it. You could write these in any order. Well, we want the 20x first, but you could write x minus 6 first and then x minus 5. You can swap these parentheses. That doesn't change the value at all. Any questions on fully factoring things? Okay. Can I do another one with 4 terms? Yeah, I have to find one though. Okay, this should look a little weird. This problem is not in standard form. Not in standard form. I do not expect you to turn a problem to look like this. I don't expect you to write a problem like this or to rewrite it so that factoring by grouping will work this way. In fact, I don't even know why they did it this way, but whatever. We're going to go through it. So first thing is there's a greatest common factor. We could take a 5 out of each of these things. We can't take a p though because there's not one at the end. Okay, so then it'd be 5p cubed plus 5p minus... Oh, wait. No, it's not. No 5s. Sorry. 5 times p cubed plus p minus p squared minus 1. Ignore that. All right, and then I'm going to group things. Now, these first two things are going to be my first group, and these two things are going to be my second group. And I also want to include this negative because I think we're going to factor a negative 1 out of here. And so it's 5 times, I can factor a p out of this, so p times p squared plus a 1. And then I can take a negative 1 out of here, minus 1 times p squared plus 1. And so this is the same, and this is the same, so those go together. Left with 5 times p minus 1 times p squared plus 1. Now, add that error there. The thing that can get confusing is because there's this 5, there's these extra parentheses, right? Those blue parentheses, we can kind of ignore them when we're doing the factoring by grouping. I don't really understand why they don't have it in standard form. You should just get the same thing. But whatever. Yeah, because if you do standard form, then it's 5 times p cubed minus p squared plus p minus 1, and then it's 5 p squared p minus 1, oh, not a parenthesis, plus p minus 1. And so we get 5 times p squared plus 1 times p minus 1. I don't know why they didn't write that problem in standard form. You get the same thing both ways. Those two things are equal to each other. Okay.